All right, great. Thank you very much. I won't spend too much time on Exascale, mainly because Earl didn't give me a lot of time on the agenda, but we have the folks coming up, speakers who are really the people who should be sharing the information on what's going on in their Exascale projects. So I'm just going to give a relatively quick overview of what we're doing. Just a quick summary on what's happening in the projected Exascale dates and suppliers that we're looking at. We're tracking really 4 major efforts: US, EU, China, and Japan. And in the EU, we'll start out with the US right now. Basically, the bottom line here is we're looking at nowadays at about $600 million a system, plus some pretty heavy R&D investment, NRE activity going on to field those kinds of systems. We're looking at peak Exascale systems to be available in perhaps the 2021 timeframe, with sustained Exascale in 2022, 2023. There are a number of really interesting programs going on within Department of Energy, a bunch of interesting different architectures and options to look at how to reach Exascale. And just one interesting note to jump in here. I was down at Oak Ridge a couple weeks ago looking at the new Summit system, and one of the things I found most fascinating about that project was that when they originally announced that the system had been stood up and talked about it at ISC in Frankfurt a couple months ago, they actually had an application that was an artificial intelligence-based program that they cited that they had achieved an exaop of operations, which is particularly impressive. But what made it more impressive is when I was down there a few weeks ago, I basically challenged them and said, so where in the RFP when you stood up this box was artificial intelligence applications? And the answer was none. We pretty much did this on the fly. While the machine was being designed and manufactured, they basically brought in an entire new class of applications. And I think that's something that those of us in the HPC community are going to need to think about, is that we're in a stage right now of great change and great turmoil, and the best laid plans have to react to changing applications and such. And I think Summit did a spectacular job kind of jinking over to exactly and to meet a new application base. So we're going to have to see more and more of that. So the Exascale systems that we are looking at today for 2021, 2022 may be doing a whole bunch of different classes of applications in a way that we have never really seen before. We can't predict what kinds of applications are going to be driving these systems as they look at sustained performance. So I think we're really looking for some really interesting developments in the next few years to see how these new designs can react to what the technology and the user base is looking to accomplish. The EU we'll hear more about that from Leonardo in a little bit, but fundamentally they announced a somewhat of a rescheduling of their Exascale program, pushing back the date of some of the availability of their Exascale systems to 2022 and 2023. And the reason that they moved it back was to give the European community time to really think about developing an indigenous processor. There was some really interesting efforts going on in something called the EPI, that again you'll hear more about, but it's basically this is actually a trend that we're seeing more and more of, the idea that indigenous processor development is becoming a fundamental reality within the Exascale development programs in almost every nation around the world. We're seeing that in Japan. They're looking to produce a system in about 2022. Actually, I think it's going to be a little bit earlier than that, but that system is going to use fundamentally an ARM-based system that Fujitsu's building for them, and it's a wonderful chip. They made some announcement at Hot Chips a few weeks ago, and it's that particular processor is going to be a real barn burner. But because of the development cost, that system is going to top out most likely at over $1.1 billion to actually get that machine up and running. We're looking at China right now. Lots and lots of activity going on in China. They have 3 different programs, Exascale prototypes, and ultimately going to pick 1, perhaps 2 winners. But we're starting to see indications that those programs are slipping. And the early peak Exascale ambitions of 2020, I suspect, aren't going to happen. It may be closer to 2021 or perhaps even 2022 before they reach the kinds of systems that perhaps only 2 or 3 years ago they were predicting would be out, frankly, 2 years from now. And part of this, we think, is because of the need for the Chinese architectures to address some of the interesting new use cases that they see coming down the road. So it's very interesting. One other thing that I just wanted to mention real quickly, and there's an interesting statistic about Summit that kind of jumped out at me when we were talking down there a few weeks ago, which is that 92% of the performance capability of Summit come from accelerators, come from the GPU capability. Only 8% of the cycles are coming from CPUs. And what I'm likening this to is what we saw in the early days when Cray came out, and all of a sudden, if your application ran vector, it ran fast, and if it didn't run vector, it became less relevant. And then when clusters came out, if your application parallelized well, it ran fast, and if it didn't, it wasn't very interesting. And I'm just wondering if we're going to start to enter an era where if your application is GPU amenable, it's going to run really fast, and if it doesn't, it's going to have to sit in the second row of the application suite. So I'm looking to truly try to understand exactly where we're going to be going with the increasing reliance on GPUs to deliver computational performance and how that ultimately affects the application base. And I think we've started to see that already with the AI applications, particularly in deep learning, which are so amenable to GPUs, and those are the ones that are really jumping to the fore when it comes to interesting applications. So I just throw that out there as something to think about. That 92% number kind of shocked me. It's not, the math isn't terribly hard, but I think the analysis that follows from that insight can be pretty interesting. Just to give you some sense of numbers going on here, U.S. right now in terms of exascale investment levels, about $1 to $2 billion a year, investments by both governments and vendors, and again, ultimately the plans are to purchase multiple exascale systems each year once the systems start to roll out. The EU, about €5 to $6 billion in total. That extends to the out years. And again, we're seeing large EU CPU funding as a fundamental element in their exascale development program. China, about $1 billion a year in R&D, and we go around all about this sometimes, about how hard it is to really measure what the Chinese are doing in terms of investment. Some of their sites don't count certain costs that we would count in other parts of the world, and there's lots of interesting issues with the Chinese, but so I'm not a big fan of dollar-to-dollar comparisons, but it's really fair to say that this is a firm commitment from the Chinese government and the vendors to actually participate in the exascale race, and I don't think they're going to suffer from a lack of funds moving forward. Japan, as we said, they're looking at about a $1.1 billion investment. A significant amount of that money has already been committed by the government, and they're looking to kind of just finish out that little margin of $200 to $300 million. They'll get it, I suspect. But again, that's going to be a very, very expensive machine. But we've looked at the architecture, we've looked at the plans, and I can tell you right up front, they're spending every dollar very wisely. It's going to be a really interesting box to look at. These are just a quick chart of some of the announced Chinese exascale plans, and these are the three prototype vendors, Sunway, Shugan, and the NUDT box. And there's nothing terribly surprising here, except if you look at the estimated delivery dates. I update that basically every quarter as things are delayed. The dates have been pushed back. One of the trends we're seeing, and I don't think this will surprise a lot of people, is we're looking at kind of a de-emphasis in terms of LINPACK efficiency. That doesn't seem to be a critical design point as it used to be in the old days. And so when people say, oh, you're really down on this box because you're only talking about 60% efficiency, we say, no, we're not down on it. It's just the fundamental realities is that that's not a key design parameter like it used to be. So we're expecting to see a gradual decline in LINPACK efficiency over time. It doesn't mean anything terrible. It just means that what LINPACK values and what the rest of the world may be designing for is diverging reasonably fast. The exascale plans, again, there's three prototypes out there. We don't know which one or two or perhaps three may ultimately be selected. The one thing I will point out to you, which I find fascinating about the Chinese HPC sector, is you'll notice that the main vendors of Chinese HPCs from a top 500 list perspective, Lenovo and Lenovo is not here. There is a great divide between the organizations that build the exascale systems, the one-off top 10 kinds of systems, with the commercial Chinese HPC vendors. I don't know exactly what that means, but ultimately what I think it means is that there is not a lot of technology discussion or flow or cooperation back and forth between the two entities, and I think that the Chinese could be suffering a bit by having less participation in the overall development of HPCs bound for not only the top 10 list, but bound for the Chinese, the commercial sector by the Chinese suppliers. So I think that's an interesting issue, and I'm looking for the Chinese to perhaps address that in the next few years. So if we look at the summary, as we said, we're looking at NUDT, Sunway, and Shugan. Again, these are not leaders in the Chinese commercial sector. Lenovo and Inspur are really not players there. The big thing here is the hardware dependence in China is really deepening. We're seeing U.S. chips being replaced by Chinese processors. Lots of variety, lots of innovation, but they change every generation, and the ecosystem has to be rewritten. So it creates lots of complexities. In my mind, they're paying a significantly high price for indigenous processor capability at this point, but it allows for some interesting architectures, and performance, I think, in certain applications could do very well. Yeah, Deborah.
Thanks, Lloyd. So given the sort of the growth of, like, particularly the hyperscale guys like Huawei and such, do you think that you'll have this kind of bimodal ecosystem, one that's kind of standard, sort of general purpose chips like Intel, AMD, and then this indigenous, or do you really think that the more sort of the current ecosystem is going to get squeezed out? I mean, do you see like the BAT vendors snapping to indigenous CPUs anytime soon?
What I see really is it seems that the technical hurdles to designing your own processor have diminished significantly over the years. You can design a chip, you can toss it over to TSMC, and you get the chip you want.
Yeah.
And to me, if nowadays, if you want exascale performance, you're looking at $500 million or more. Suddenly, the chip cost development is not as onerous as you'd think it'd be. And so I think that these large government-funded efforts to build exascale and beyond systems, it's almost within budget to develop something that is much more custom, much more suited towards your application base, and is not something that is just simply, quote, off the shelf.
Right, but do you think that will bleed into the broader China market in any meaningful time frame?
I don't see any mechanisms to allow that to happen, other than serendipity at this point.
Okay, so it's kind of like insulated into that. Thanks.
Exactly, yes.
Can I just offer a very quick comment?
Sure.
Just from my interactions with those vendors, they are, Lenovo, Inspur, Huawei, they are very sensitive about security issues, technology issues, and so they are deliberately staying out of the exascale discussions. Because they don't want to taint their market opportunities.
No, especially as I think as they want to really expand their presence globally, they probably want to stay out of the national security environment as well. So yeah, I think that's a really good point. But again, the indigenous hardware dependence deepens. We're seeing, as I said earlier, we're seeing that around the world. Indigenous processor development to meet unique requirements seems to be the theme, one of the major themes of exascale development. I just want to touch very briefly on what's going on in the EU right now. January of this year, they basically stood up a framework, a joint undertaking where they had 20 different countries at this point sign up to basically combine efforts to basically build 2 pre-exascale and 2 exascale systems for availability in, as I said, 2022, 2023. And the pushback really was to give time to develop a new EU processor. And as I said, 20 member states, and there's lots of interesting collaborations going on here across the EU, and also we're seeing some interesting stuff going on in terms of with EU cooperation with RICAN on some interesting ARM developments as well. So that may give you a hint, or at least a sense of where the indigenous European processor ultimately will look like. They're not only thinking about developing an indigenous European processor, but also an accelerator based on the RISC-V architecture as well. So again, indigenous is a theme there, also with an accelerator that sits behind a general purpose CPU. Really, the driver behind the motivations for this particular project is really to secure EU's independent access to HPC technology. The EU is a large consumer of HPCs, and I think rightfully so wants to stand up and say, we can also supply technology as well. There's lots of expertise in the EU about using HPCs, and it's really, I think, an important aspect of their ability to maintain their capabilities to continue to develop indigenous technology. Yeah?
Are you seeing Brexit induce a schism between what the EU's been doing and what they're going to do with Britain parts ways and what? Can you repeat the question?
Yeah, what's, go ahead.
Brexit splits the EU up, does it or no?
I haven't, you can address this question, it's probably much better than I can, Leonardo, but I haven't seen this to be as impactful as I think people thought in the early days of Brexit. You can talk about it a little later, yeah. So in summary, Oh, this time I'm jumping all over Earl's chart here. Okay, in summary, HPC is still expected to be a growth market, and there's certainly a growing recognition of strategic value for the traditional modeling and simulation, national security applications, economic competitiveness. We're looking at increasing growth and interest in HPDA, including machine learning, deep learning. The cognitive and AI aspect of HPC is a force to be reckoned with in the next few years, and is really going to, I think, be one of the more important and basically most used use cases out there in the next few years. And we're really thinking about HPC in the cloud. We're trying to get a handle on that, and I know Alex is working feverishly on really trying to assess how much interesting good work is being shipped to HPC in the cloud environments that's worth talking about. It's not just basically sending up some simple offloaded work that could have been done anywhere. It's compelling HPC work in the cloud, and I'm really anxious to see, or excited to see what that sector produces in the next few years. Vendor shares shifted greatly in 2015, 2016, and 2017. HPCE acquisition of SGI, Lenovo buying IBM's x86 server. The number of players is, I think it's fascinating that the others category is so large. The barriers to entry of HPC right now seem to be relatively low, and there's lots of capability out there, and there's lots of options. I think the fact that Cray can offer an ARM-based processor, an ARM-based system right now, is a really interesting way that says even a relatively small company has the wherewithal to switch processor bases. The barriers to entry and the design options that are available out there, I don't think have ever been greater. And so I'm looking for much more variety in HPC design and a lot more interesting, I almost want to say bespoke HPC systems. This is my application. Let's go out and build a system that actually meets that. I don't need to buy an off-the-shelf HPC. And finally, the big HPDA, AI, machine learning, and DL markets will expand opportunities for the vendors tremendously. And this just doesn't mean offering a board with GPUs on the back. It really means trying to take the customers by the hand and really help them understand how their particular vertical can benefit from this AI phenomenon. So that is the questions, and not too bad. See.